Yeah. So in the today's sessions, what we are dealing, we are going to complete the concept of the motion in a plane, which is the third chapter in your part 1. Correct, no?
Yes, students, please respond.
Yeah. In this motion in a plane, we have a two parts here. One is the vectors and the projectile motion. Projectile motion, and only the two concepts were deleted from the motion in a plane. One is the relative velocity concepts and the multiplication of the vectors. But in coming chapters, you have to learn the multiplication of vectors. But here we are not learning that. Only we are learning the addition, the subtraction, and the resolution of the vectors. For your board exams, nearly you are going to get around 14 marks for your board exam. So one derivation and one numerical value is a must from this chapter. So 4 mark is going to be divided for 1 mark MCQs or 3 mark question or 2 mark question and 1 mark MCQ, 1 mark fill in the blanks. For your competitive exams, you are going to get 2 questions for your NEET and Karnataka CET, and for your JEE, you are going to get 1 question from this. But maybe this question goes with case-based study question also in the choice of JEE, but not sure. But this is compulsory question for medical as well as for CET. Yeah. First, let me talk about the vector, students. Let me do it fast by one, how we can analyze the concepts. Now, suppose if I'm talking about a physical quantity, can you tell me what is physical quantity? That quantity which can be measured very accurately, isn't it? So the quantities which can be measured very accurately are considered as a physical quantity. Can you give me the examples?
Velocity.
Okay.
Force.
Force, velocity, fine. Then?
Acceleration.
Okay, acceleration.
Displacement.
Displacement. Then?
Length.
Yeah, length.
Speed.
Pardon?
Speed.
Yeah, speed.
Time.
Time. Pressure. Density. Correct, no? Momentum. Look at this. In this, you can notice that all these quantities which are in the first column, they have only the magnitude, there will be no direction. There will be no direction. But in the second case, in the second column, the quantities which are there, they have both magnitude and the direction, isn't it? So the quantities having both magnitude and the direction is considered as what? Is considered as what?
Vectors.
Very good, vectors. So what are vectors? Vectors are the quantities having both magnitude and the direction. How this vector is represented? This vector is represented by a straight line with an arrow mark. Vector is represented by a straight line with an arrow mark. So this is how we represent the vector. This A is called as the initial point. B is called as the final point. So this AB vector is written like AB. Over that AB, we are putting one arrow mark like this. This is read as AB vector. Or you have to write this as vector AB. Vector AB. So in the vector AB, can you tell me which is the initial point? Which is the initial point?
A, sir.
A. Which is the final point?
B.
B is the final point. Suppose if I considered a vector PQ. If I considered a vector PQ, in this vector PQ, can you tell me which is the initial point?
P, sir.
P. Good. What about Q?
Final.
Final point. Yeah. Now I'm going to give one more vector, Appa. I'm going to give one more vector. Let us say CD is the vector. Can you tell me which is the initial point?
D, sir.
C or D?
C.
Okay. Why not D?
Sir, arrow mark is not given, sir.
Yeah, that is required. Here we cannot tell which is the initial and which is the final because I have not mentioned the arrow mark. So if I mention the arrow mark like this, then C represents the
D, sir.
initial point, then D represents the final.
Final.
So you came to know what is vector. Vector is having both magnitude and direction. And how to represent vector? It is represented by a straight line with what? With what?
Arrow mark.
Arrow mark. Yeah. Now, in this vector AB, there is both magnitude and direction, isn't it? Here, whatever AB vector is there, for that AB vector, we are dropping a two parallel lines here. This parallel lines, usually we call it as a modulus of vector AB. This modulus of vector AB gives the magnitude. It gives what? Magnitude. So how the magnitude of the two vectors are represented? Magnitude of the two vectors AB is represented as modulus of what? AB vector. Modulus of AB vector represents what? The magnitude. Yeah. You can consider the example, students. Suppose if I considered a vector here. This is AB vector. I will represent this with some force. Let us say some 10 Newton. Can you tell me the direction of this force? It is from A to B or B to A?
A to B.
So here the force is a vector actually. It is acting from A to B vector, that is AB vector. Can you tell me what is the magnitude of AB vector?
10.
Magnitude means only the number, that is this. That is magnitude of AB vector is 10 Newton. So 10 is the magnitude here. No need of representing the vector notation there. Yeah. Suppose if I considered a vector whose the magnitude of the vector is 1. Magnitude of the vector is 1. If the vector is having a magnitude 1, please remember it is considered as a unit vector. What is unit vector? Unit vector is the one whose magnitude is 1. Suppose if I say AB vector is this, A to B, AB vector is this, I will denote the unit vector with n cap. What is n cap? This is the symbol how you represent the unit vector, students. N cap is the unit vector of AB. How do you define this n cap unit vector? To get the unit vector n cap, please remember you have to write the AB vector divided by the magnitude of this vector. What is the magnitude of that vector? Magnitude of AB. So how do you define the unit vector? Unit vector is defined as the magnitude of AB vector divided by the magnitude of AB vector. This is how we represent the unit vector. So what is unit vector? Unit vector is the one whose magnitude is how much? 1. Now, suppose if I consider the magnitude of the vector is 0. Magnitude of the vector is 0. If any vector is having a magnitude 0, then what is that called? Come on. If the magnitude is 1, it is called unit vector. No. If the magnitude is 0, zero vector. This zero vector is also called as what? Null vector. Yeah. Let me consider one OA vector. Which is the initial point, students? O. Let me consider one more vector. OB. Let me consider one more vector. OC. How many vectors are there?
3.
3 vectors. Good. For all these 3 vectors, is the initial point is same or different?
Same.
Same. If the vectors are having same initial point, such a vector are considered as a co-initial vector. Co-initial. Yeah. Suppose if you consider the 2 vectors, this is one vector, AB.
I think screen is not yet visible, sir.
Now, suppose if I consider the 2 vectors like this, one is A vector, I mean initial point, B is the final point, this is AB vector. I'll consider one more vector, students. Let it be CD vector. C is the initial point, D is the final point. Suppose if I say AB vector is equal to CD vector. What is the meaning? If these 2 vectors AB and CD are equal, that indicates both magnitude and directions are same. 2 vectors of equal magnitude are acting in the same direction. Such a vector, we call it as a like parallel vectors, or simply we can call it as the equal vectors. So when the two vectors are said to be equal, if they have both magnitude and directions same. Suppose I will keep AB vector as it is. I will change the CD vector direction. Clearly, we can say that the magnitude of AB vector is equal to the CD vector. Magnitude are equal, but what about the direction? The direction is opposite, isn't it? If the direction is opposite, then you can put a minus sign. Then we can say that AB is the negative vector of CD, or CD is the negative vector of AB. So AB is the negative vector of CD, or CD is the negative vector of AB. Clear? Okay. Now, please remember this, a very important concept, students. We have a three standard symbols in the vectors. One is I cap. The second one is J cap. The third one is K cap. I cap, J cap, and K cap. Suppose if I want to represent some force, let us say F is equal to 10 Newton. Now, I won't mention the coordinates here. Is it possible for you to tell the direction for this? Force is 10 Newton is acting in one particular direction, but I'm not giving the initial point or final point, whatever it is. Is it possible to tell in which direction it is acting? Not possible, right? In this case, we are going to represent the vector by multiplying with a unit vector. We are going to multiply the number with unit vector to give that direction. Please remember, if I say the unit vector, it may be I cap, J cap, or K cap. If I say 10 I cap, please remember, this force of magnitude 10 Newton is always going to act along x-axis. If any vector is acting along the x-axis, we are using which symbol? I cap. So I cap is the unit vector which is going to act along x-axis. What about J cap? Similarly, it is the unit vector acting along y-axis. What is K cap? It is the unit vector acting along z-axis. Suppose if I say this is x-axis, this is O, this is y-axis O1. If I say 3 I cap, how you will represent 3 I cap? How will you represent 3 I cap? Along y-axis, no? Along y-axis, no?
Along x-axis, sir.
Along x-axis, good. So OA is 3I. If I give 4J cap?
Along y-axis.
Along
y-axis.
OB. Yeah. Can you tell me the magnitude of OA, my dear? What is the magnitude of the 3I cap? Three, no. What is the magnitude of 4J?
4.
4.
4.
4. Yeah. Now we have individually given 3I and 4J. Now I will give one PQ vector, let us say, athwa OP vector. Let us say OP vector is 3I plus 4J. OP vector is 3I plus 4J. Now, can you tell me how to show that OP vector in that graph? It is acting along x-axis or y-axis? It has both I cap and J cap, no?
Yes, sir.
When it is having both I cap and J cap, it should move like this. So this is OP vector. This OP vector is having 3 along x-axis and 4 along y-axis. X-axis ಅಲ್ಲಿ 3 ಇದೆ, y-axis ಅಲ್ಲಿ ಎಷ್ಟಿದೆ? 4. Now, can you tell me the magnitude of OP vector? What is magnitude of OP vector? How much it is?
5.
Very good, very good. 5. Just use the Pythagorean theorem, no? 3 squared plus 4 squared, that will be 5. So 5 is the magnitude of that vector. Okay. Now let us continue that in the standard format. If I represent one vector, a vector, like 3i plus 2j, can you tell me the magnitude of this a? Simple. Put the root. Take this square. 3 squared plus 2 squared. This is root of 9 plus 4, no? Root 13. The same concept how you have solved for 3 and 4. You can do it here. 3i plus 4j. What is the magnitude you have told? What is the magnitude you have told? 5, no? How you got this 5? Root of this squared plus this squared. 3 squared 9, 4 squared 16. So what is 9 plus 16?
25.
Root 25 is nothing but what? 5. Now, tell me for this, B vector is 1i plus 2j. What is the magnitude of this? Patapat, fast. Estotro, it is very simple, no? Root of 1 squared plus 2 squared. Now I'm going to take in general. In general, if I represent AB vector as x into I cap, y into j cap, z into k cap, can you tell me what is the magnitude of AB vector? Root of
X square plus y square plus z square.
yeah, x squared plus y squared plus z squared. This is the magnitude of AB vector. So you got to know how to find the magnitude of the given vector, isn't it? Root of x squared plus y squared plus z squared. Yeah. Now, let me take the very important concept, students. That is position vector. Position vector. What is position vector? What is position vector? Suppose if I considered, let us say, this is AB vector, appa. AB vector. Can you tell me the initial point? A is the initial point, B is the final point.
Final.
Now, suppose if I fix the origin, you fix the origin first. From the fixed point origin, you join one vector, that is OA vector. Then you join one more vector, that is OB vector. This OB vector is called the position vector of B. OA vector is called the position vector of A. If you want to find what is AB vector, Please remember it is OB vector minus OA vector. Position vector of B minus position vector of A is called as the vector AB. So what is vector AB? Vector AB is equal to what? Position vector of B minus position vector of what? A. So final position vector minus initial position vector gives the position vector of AB. Now, if I want to find the position vector of PQ, how will you write this position vector? Fast ಹೇಳ್ಬೇಕು. OQ vector minus OQ vector minus OP vector. ಫೈನಲ್ ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ಬಂದಿರೋ ವೆಕ್ಟಾರ್ ಮೈನಸ್ ಇನಿಷಿಯಲ್ ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ಬಂದಿರೋ ವೆಕ್ಟಾರ್ ಅವೆರಡು ಡಿಫರೆನ್ಸ್ ತಗೊಂಡ್ರೆ ದಟ್ ಯು ವಿಲ್ ಗೆಟ್ ಎ ಪೊಸಿಷನ್ ವೆಕ್ಟಾರ್. ಸೊ ಪೊಸಿಷನ್ ವೆಕ್ಟಾರ್ ಇಸ್ OQ minus OP. Now, can you tell me what is the position vector of XY?
OY minus OX.
OX, yeah. Final point to the position vector minus initial point to the position vector. This is how you are going to calculate the XY vector. You got the concept of position of vector? Okay. Now, find magnitude of AB vector. Find magnitude of AB vector upper. I will give OB vector 2i plus 3j, OA vector I plus 2j. Now I want magnitude of AB vector. To find the magnitude of AB vector, first you have to find AB vector, isn't it? What is AB vector? OB minus OA. OB vector is 2i plus 3j. OA vector is I plus 2j. What is 2i minus I? So 1i plus 1j. This is AB vector, isn't it? Now, what is magnitude of AB vector? Magnitude of AB vector is root of 1 squared plus 1 squared. Root of 1 plus 1, that is root 2. So this is how we are finding the position vector of AB and the magnitude of AB vector. You got my point? So this is how we are finding the position vector AB. Yeah. Now, let us take the next important concept, that is addition of two vectors. Addition of two vectors. Students, here you have to be very extra smart when you want to add the vectors. It is not like your normal algebra to add the two numbers. Suppose if I consider the two vectors here, let us say this is AB vector. Let us say this is P vector. This is AB, P vector. I'll consider one more vector, that is BC. That is BC. Now, let me consider one more diagram. Let me consider one more vector. Let us say this is OA vector P. I'll consider one more vector OB, that is Q vector. Can you tell me the difference between these two diagrams, students? Look at this. In the first case, we have taken the two vector continuously in the same order. But here, the two vectors are having the same initial point. Between P and Q, the same initial point we have. But in the first case, A is the initial point. For the second vector Q, we have the initial point B. So in the first case, the two vectors are represented in the same order. But in the second case, the two vectors are having the same initial point. Now, in the first case, you just complete the third side of the triangle and you please take this in the opposite order. You take it in the opposite order. The third side of the triangle, which is taken in the opposite order, gives the resultant of these two vectors, that is R vector. So what is R vector here? It is P vector plus Q vector. So how to write the resultant vector for the triangle? You have to draw the third side of the triangle, but the third side must be written in the opposite order. In which direction the P and Q are coming, opposite to that you have to show to represent the resultant. Be careful. In the case of this case, here we have a same initial point, isn't it? Now you take one vector parallel to Q. You take one more vector parallel to P. So this is P and this is Q. Now it becomes a parallelogram. In this parallelogram, you draw the diagonal passing through the same initial point. Don't write this diagonal, A to B diagonal. Don't write A to B or B to A diagonal. You write the diagonal passing to the same initial point. That is what we called as the resultant vector of this P and Q. So R vector is what? P vector plus Q vector. So result will be the same. But this is the first one is called as the triangle law of vector addition. The second one is called as the parallelogram law of vector addition. So in the vector addition, we are using the two methods. One is triangle law. The second one is parallelogram law. Students, be very careful. If the two vectors are having the same initial point, you go for parallelogram law. If two vectors are in the same order, then you go for triangle law. Got it? Yeah. Now, I'm just writing the two vectors like this. Can you tell me it is triangle method or parallelogram method?
Triangle method.
Very good, very good. Triangle method. Shall I write RP or P to R?
P to R.
Very good. Very good. P2R is the resultant. Yeah, good. Now, one more example. This is triangle. This is A. This is B. This is C. A. This is C. This is B. Among A, B, C, can you tell me which is the resultant? Vector A is resultant, or vector C is resultant, or vector B is resultant?
Vector B.
Why vector B is resultant, Appa? Good, good. Why
Because
vector
it's
B is
taken in
resultant?
the opposite order.
Yes, exactly. Here C and A are in the same order. So definitely B must be the resultant vector here. So B vector is A vector plus C vector. Good, good. This is A. This is B. This is B. I will tell this is A and this is B and this is C. Can you tell me B to C is the resultant or C to B is the resultant? B to C is the resultant or C to B is the resultant?
Depend on direction, sir.
No, I have given the two vectors, right? A vector I have given, B vector I have given. Now I have written the third side also. Tell me which is the resultant, B to C or C to B?
Is it C to B?
C to B? Okay. Can you add these two vectors by using triangle law?
No, sir.
No, sir.
That is what I'm expecting from you. We cannot add this by using triangle law. Then which method you have to go for?
Parallel.
Exactly. So you draw one more vector parallel to B and parallel to A. Correct? Huh? So you will get something like D. This is A vector. This is B vector parallel. Now, BC diagonal will give the resultant or A to D diagonal gives the resultant?
A to D.
A to D gives the resultant. Good. A to D gives the resultant. I think you got my point, right? Yeah. This is A upper. This is OA. This is OB. B vector. Can you tell me it is triangle method or parallelogram method?
Parallel.
Parallelogram.
Very good. Very good. So I will write one more parallel here. I will call this point as C. Shall I write A to B as the resultant?
No, sir.
O
No.
to C.
Okay then. Okay then. Shall I write A B to A?
No, sir.
Then
O to C.
very good. Very good. O to C represents the resultant. You got my point? Okay. Students, maybe this question may be going to be for 5 mark, very important for the board exam as well as for the coming quarterly test. Derive an expression for the magnitude and direction. Derive an expression for the magnitude and direction of two vectors. Using law of parallelogram. So look at the question carefully. Look at the question carefully. You have to derive an expression for what? Magnitude and the direction of two vectors. Two vector using which method? Law of parallelogram. Okay. Now, let me consider the two vectors. Let me consider the two vectors. This is OA, P. Shall I write one more vector from A or from O? You want one more vector? No. Shall I write that one vector from A or O?
O.
Because I have to use parallelogram. OB. This is Q vector. Let us say the angle between these two vectors is theta. What is theta? Angle between the two vectors. Shall I write parallel to OA? Shall I write parallel to OB? Let us call this as C. Now, which is the resultant, students?
OC.
OC.
C.
OC is the resultant. Very good. OC is the resultant. Now, if I drop one line here, perpendicular to extended line OA, I'll extend the line OA. For that, I will write one perpendicular line here. If this is theta, then this should be theta according to your corresponding angle. This is Q. This is P. Now, in the triangle OCD, I will use the Pythagoras theorem. Can you tell me the Pythagoras theorem for OCD?
OC square is equal to OD square plus CD square.
Very good. Then OD can be split into two parts like OA plus AD. Look at the diagram. O2D can be taken as OA plus AD. So expand this. OA squared plus AD squared plus 2 times of OA into AD plus CD squared. OC squared equals OA squared I will keep as it is. AD squared plus CD squared. First I will write this AD and CD squared. Plus 2 times of OA into AD. I don't know what is ADCD and also I don't know what is the value of AD. Now, using the triangle ACD, by using the triangle ACD, can you use the Pythagoras theorem? AC squared equals AD squared plus CD squared. Can you tell me what is cos theta? Adjacent AD by hypotenuse AC. So what is AD from this? AC into cos theta. Therefore, OC squared is equal to, what is OA? P squared plus AD plus CD is nothing but AC squared. AC value is how much? Q squared plus 2 times of OA is P, AD is AC cos theta, but AC is Q, so it becomes Q cos theta. So OC represents the resultant. To remove this square, I'm just putting the root. So what is the resultant vector? P squared plus Q squared plus what? Two PQ cos theta. So what's the formula for the magnitude of the resultant vector, students? R equals to root of P squared plus Q squared plus 2PQ cos theta. This is the magnitude of the two vector using the law of parallelogram. Now, if you want to make use of the concept of direction, to find the direction, we are going to consider that resultant is going to make an angle alpha to measure the direction. So from the triangle OCD, you can take what is tan alpha. Tan alpha is opposite CD by adjacent, that is OD. Now OD can be taken as OA plus AD. So tan alpha equals, CD value is nothing but, here if you apply sin theta in the same triangle, opposite is CD by hypotenuse is AC. So CD value will be AC into sin theta. So CD value is AC sin theta, whole thing divided by OA plus AD. If you want only alpha, you can shift only the function tan to the right side, students. It becomes tan inverse. Tan inverse. What is AC from the diagram? Q sin theta by P plus Q cos theta. So to find the direction, please remember, students, to find the direction alpha, what is the formula we are using? Tan inverse of Q sin theta by P plus Q cos theta. So this is how we are finding the direction of the resultant vector of the two vectors by using the concept of parallelogram law. If they are asking for 5 marks, usually they will ask both magnitude and the direction, students. You got it? Okay. Now, what is the formula, students, you have studied for magnitude of the resultant? Root of P square plus Q square plus 2PQ cos theta. Now, if I consider the two vectors P and Q are in the same direction, can you tell me what is R? What is the angle between P and Q?
0.
Yeah, angle theta is 0. Good. If I put this theta here 0, what is cos 0?
1.
1. So 1 into 2PQ will be just 2PQ, right? So what is the format? Root of P square plus Q square plus 2PQ. No, that can be written as P plus Q whole square. Square and square root. Cancel out. What you will get for R? P plus Q. So please remember, if two vectors are in the same direction, what is the resultant? P plus Q. If two vectors are in the opposite direction,
P minus Q.
very good. Theta just becomes 180 degree. Theta becomes 180 degree. So cos theta will be 180. Cos 180 will be minus 1. So the formula will be P squared plus Q squared minus 2PQ. So it becomes P minus Q. If two vectors are perpendicular, perpendicular means what about theta?
Root of P square plus Q square.
Very good. Very good. So please try to remember this 3 formula, students. It must be in your mind always. If two vectors are in the same direction, just add up. If they are in the opposite direction, just subtract it. If they are perpendicular, take the root of p squared plus q squared. A very, very important. They may ask for fill in the blanks or in 1 mark MCQs like that. This is one vector P. I'm writing the second vector Q. I'm giving the Q vector is also equal to P. So I'm considering the equal vectors. But the angle between them is 120 degree. Angle between the two vector is 120 degree. So I want what is the resultant here. The resultant somewhere will act here. I want what is the resultant equal to. Theta is 120, so cos 120 value will be minus of, for your reference. Cos theta value will be minus of. Tell me what is R. Mind madi. You can do it in the mind calculation. No. Don't write everything. P squared plus Q squared plus 2PQ. In the place of cos theta. In the place of cos theta.
Minus 1 by 2.
So 2 and 2. P squared plus Q squared minus PQ. Correct? No? Root of P squared plus Q squared minus PQ. P and Q are equal, right? If P and Q are equal, what will happen? P squared plus P squared minus P squared, no. So plus P squared minus P squared will cancel out. So left out with only root of P squared. What is root of P squared? P. So please be very careful. If two equal vectors is acting and even the resultant is also equal to that vector, then what is the angle between the two vectors? 120 degree. They will put in the MCQs. The resultant of two equal vector is equal to the given vector. What is the angle between them? 120 degree. If two equal vectors are acting at 120 degree, then what is the resultant? Resultant will be same as the given vector. This is possible only if the equal vectors are acting at 120 degree. Got it? Okay. These are all important. When we are solving the objective, we are taking all this directly. This is also very important, students. That is resolution of a vector. Resolution of a vector. Suppose if I give a vector here, let us say this is vector A. Now you can split this vector into two rectangular components. Two rectangular components. So those two components must be always perpendicular. If this vector makes an angle theta with this component with x-axis, if I say this is origin and this is y-axis, if the vector A makes an angle theta with x-axis, please remember that component goes always with A cos theta. The another one will go with A sin theta. So the vector makes an angle theta to one of the component. For which component it makes an angle theta, that always goes with cos. The another component will be sin. It is just the basic definition of trigonometry. Now, I am going to give this is one vector, let us say P. Shall I split this P into two components? One is along OX, the another one is along OY. If I say the vector P makes an angle theta with OY component, then can you tell me what is OY?
P cos theta.
Okay. What about OX?
P sin theta.
P sin theta. Yeah. Good. Now, I'll give one more vector like this. Let us say this is X, or you can take P only. This is P. This is OX. This is OY. Can you tell me OX is P cos theta or P sin theta?
Cos theta.
OX is
Cos theta.
P cos theta. Hemant Gowda,
Sir,
can you tell it is P cos theta or P sin theta?
sir, P cos theta.
Why not P sin theta?
Because it's running along the x-axis.
See here, what I've told, the component which makes an angle theta, that component goes with cos, isn't it? Yes or no?
Yes, sir.
Where is theta, my dear?
P
There
sin
is
theta.
no theta.
I have not given the theta only. Then how can you tell it is P cos theta or P sin theta? Not possible. You got my point. Without knowing the theta, you can't tell which is cos or which is sin. If I say this is theta, now you can tell this is P cos theta and this is P sin theta. Right? Yeah. One more question. This is one vector. This is, let us say, M. This is OY. This is OX. OX. Let us say this is P. OP is M. We'll write OM as M cos theta, OX as M sin theta. I'm giving the components. I'm giving the components to you, Hemant. Can you tell me where should I write the theta now? Theta has to be mentioned with respect to y-axis or from x-axis?
Y-axis, sir.
From y-axis, like this.
Yes, sir.
Why from y-axis? You're liking y-axis much?
No, sir, because you gave M cos theta at OY.
Exactly. Good, 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 good. Since cos theta is given along y-axis, you have to write it from there itself. So that is the procedure. Okay. Last example, students. Last example. Let us say there is some inclined plane. Something like this. There is an inclined plane. At this point, I will show downward, that is G. Downward is G. I want G into two components. I want to resolve the G into two components. So I will write G into two components. One is like this. The another one is perpendicular to that. This is OY. This is OX. OX. Yes. Now you can tell me. Now you can tell me which one will be G cos theta and which one will be G sin theta.
OX will be cos,
OX is
cos, cos, cos theta.
OX is G cos theta.
Yes, sir.
Okay. Do one thing. Now, there is x-axis and y-axis. They are perpendicular. If I tilt the x-axis, y-axis also will get tilted. Observe carefully here. This is x-axis. This is y-axis. Okay. Now, I will rotate this x-axis somewhere here. So y-axis also will get rotated, right?
Yes, sir.
This is y dash, this is x dash. If x-axis is rotated by an angle theta, then y-axis also will get rotated by. Arey Baba, if two lines are perpendicular, if vertical is displaced by an angle
Yes, sir, I
theta,
understood, sir.
horizontal also will displace by. If you push this line x to this x dash by an angle theta, automatically this y also will push to y dash, no? By what angle? Theta. So if this x-axis is pulled by an angle theta, then this y-axis is also pulled by what angle? Theta. Hemant, now you tell me where is g cos theta?
Sir, along OY.
Yeah, along OY is g cos theta, not OX. So here, how we are going to resolve this g into two components. Actually, somewhere I have given theta and I'm asking you to take theta related to g. So one is g cos theta, the second one is g sin theta. So this is how we are solving the concepts in the case of resolution of a vector. I hope you got the concept of resolution of a vector, students. Okay. Any doubt related to this addition and the resolution of vectors? Okay. Now, one last example, last example. I'm going to give one vector P, 5 Newton, along x-axis, it is equal to 2.5 Newton. What is angle theta? Question mark. No. Look at here. Look at this. If I say this is theta, definitely this will become P cos theta, right? OX is P cos theta. What is that P cos theta equal to? 2.5. So 5 cos theta is 2.5. So cos theta is 2.5 by 5. So cos theta is, what is 2.5 by 5? Theta equals what? 60 degree. There is one vector here, OP. I'm splitting this OX and OY into two components. Let us say this is 10 Newton. Y component is also 10 Newton. Can you tell me what is this theta? I want theta. I resolved P into two components. One is along x-axis, the another one is along y-axis. One is 10 Newton, the second one is 10 Newton. What is theta?
$45.
Yeah, very good. 45 degree. Why you have taken this long time? Look at these values. 10 Newton and 10 Newton, isn't it? X component and Y component are equal or different?
Equal.
Equal. When they are equal, both sine and cos should be same. For what angle the cosine and the sine will be same?
45.
Very good. 45 degree. So you can tell directly the 45 degree. Maybe they will put the question like this in fill in the blanks or in MCQs. You have to be very careful. Yes, if you have any doubt related to vectors, you can ask. At least not today only. In the next session, at least when you are revising all this vector concept from your textbook, notes, any material, if you found any doubts related to vectors, you can mark it and you can ask in the next session also.